A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello students. Welcome to the 5th week of our e-learning physics class for 3rd term. My name is Oladimeji T.A., your physics teacher. And for this 5th week, the topic of discussion is going to be reflection of light at curved surfaces. Reflection of light at curved surfaces. And under this topic, we shall consider the following subtopics: curved surfaces, spherical mirrors, image formation in spherical mirrors, uses of spherical mirrors, and mirror formula. So let's start by beginning the first period of this week, which is period 1, curved surfaces. Curved surfaces. A curved surface is one which its reflecting surface curves inwards or outward. A curved surface is one which has its reflecting surface curves inward or outward. And a perfect example of curved surfaces are curved mirrors. Curved mirrors. Curved mirrors can be classified into spherical mirrors or parabolic mirrors. Spherical mirrors and parabolic mirrors. So let's pick them one by one. Spherical mirrors. There are two types of spherical mirrors. We have concave mirrors and convex mirrors. Concave mirrors and convex mirrors. A concave mirror has its reflecting surface curved inward, as shown in figure A. The reflecting surface of a concave mirror curves inward, while a convex mirror has its reflecting surface curved outward, as shown in figure B. The reflecting surface of a convex mirror is curved outward. Yes, figure A shows a concave mirror, while figure B shows a convex mirror. Another name for a concave mirror is known as a converging mirror, while another name for a convex mirror is a diverging mirror. So we can call it a diverging mirror or a convex mirror. And we can also call concave mirror a converging mirror. The following should be noted about the two types of mirror, of spherical mirrors. 1. A concave mirror converges parallel beam of light, while a convex mirror diverges parallel beam of light. For that, number 1, let us look at how this is shown in the diagram. Look at the diagram. You can see that the blue lines represent a parallel beam of light. On striking the reflecting surface of the mirror, they are all reflected to a point, which is known as the focus, principal focus of that mirror. So they are all brought to a single focus, and that focus is known as principal focus. So a concave mirror converges parallel beam of light to a focus. That is why it is also known as a converging mirror. But look at a convex mirror. When a parallel beam of light strikes the surface of the mirror, the rays are diverged. So all the rays diverge, and when they are produced backward, it will now be as if they are coming from a point behind the mirror, which is called the principal focus of that mirror. So a convex mirror diverges parallel beam of light. That is why it is also known as a diverging mirror. But a convex mirror converges parallel beam of light. That is why we call it a converging mirror. That is all about number 1. Let's look at number 2 point that we should take note of the two mirrors. A concave mirror has a real focus, while a convex mirror has a virtual focus. What do they mean by this? Let's go back to the diagrams. You can see when the parallel beam of light strikes the mirror, they are all brought to its focus called the principal focus. So they are actually, the rays, all of the rays actually intersect at that point. That is why the focus is real. But let's look at a convex mirror. When the parallel beam of light strikes the reflecting surface, they all diverge. But when they are produced backward with dotted lines, it will be as if they are coming from that point. Actually, they are not coming from that point, but we produce them to be coming from that point. So that point is not real, it is factual. It is only when they are produced backward they will now be as if they are coming from the point. That is why the focus is factual. So we should take note. A concave mirror or converging mirror has a real focus, while a convex mirror or diverging mirror has a factual focus. Let's go to point number 3 we should note. A concave mirror forms images in front of the mirror, while a convex mirror forms images behind the mirror. Yes. Point 4. A concave mirror has a positive focal length, while a convex mirror has a negative focal length. What is a focal length? Focal length is the distance between the pole of the mirror and the principal focus. So let's go back to the diagrams. You can see the distance from P to F is the focal length. For a concave mirror, it is real because there is a real focus. But for a convex mirror, the distance from the pole to where we have F is the focal length. But since that F is not real, it is factual, then the focal length too is going to be factual. So that is why a concave or converging mirror has a positive focal length, but a convex or diverging mirror has a negative focal length because it has a factual focus. So those are the 4 points we should take note about the two types of spherical mirror. Now let's go to the terms used in spherical mirrors. The term used in spherical mirrors. The first one is the pole. As I mentioned earlier, the pole of the mirror is the center of the reflecting surface of the curved mirror or spherical mirror. The center of the reflecting surface of the spherical mirror is what we call the pole P of the mirror. The aperture is the width AB of the mirror. That is how wide the mirror is what we call the aperture of the mirror. Then the center of curvature C is the center of the sphere of which the mirror is a part. You can see the mirror, whether it is a convex or concave mirror, it's like a part of a big sphere. So when this sphere is completed, the center of that sphere is what we call the center of curvature of the mirror. So the center of curvature of the mirror is the center of the sphere of which the mirror is a part. Then the radius of curvature R, and the radius of curvature R is the distance between the pole P of the mirror to the center of curvature. That's what we call the radius of curvature. Then the principal axis. The principal axis PC is the line that is drawn from the pole P to the center of curvature. It's the line that passes through the pole to the center of curvature. It is the line that connects the pole to the center of curvature. Then the principal focus. The principal focus, the way we are going to define the principal focus for a concave mirror is a bit different from the way it is going to be defined for a convex mirror. So let's look at the two one by one. The principal focus of a concave mirror is the point on the principal axis. Yes, principal focus is always going to be on the principal axis. So it's the point on the principal axis where parallel rays close to the principal axis converge after reflection from the mirror. That is the principal focus of a concave mirror, because it's going to have a real focus. So where all the rays that are parallel and close to the principal axis will converge to after reflection from the mirror is what we call the principal focus of a concave mirror. But for a convex mirror, the principal focus is the point on the principal axis where all parallel rays close to the principal axis appear to diverge from after reflection from the mirror. Yes, a convex mirror has a virtual focus. So when the parallel rays of light strike the mirror, they diverge. But when they are produced backwards, it will now be as if they are coming from a point. So the point behind the mirror, where they appear to be coming from, is what we call the principal focus of a convex mirror. So that is why the definition does. It is a point on the principal axis where rays parallel and close to the principal axis appear to diverge from after reflection from the mirror. Then the focal length f. This is the distance pf between the pole and the principal focus. Yes, the distance from the pole to the principal focus is what we call the focal length. And it can be noticed that the focal length and the radius of curvature, they are related by the equation f is equal to r over 2. That is, the focal length is half of the radius of curvature, or the radius of curvature is 2 times the focal length. Yes, another thing you should take note is principal focus is denoted with capital letter F, while the focal length is denoted with small letter f. The focal length of a concave mirror is positive, while the focal length of a convex mirror is negative. Yes, this is where we are going to end the first period of the 5th week. Until next time, when I will come your way again, when we shall continue on the topic. Once again, my name is Oladimeji Tihe, your physics teacher. Assalamu alaikum wa rahmatullahi wa barakatuh.